some of these red areas are. And some of the criteria that they use to classify whether a coastline is sensitive to climate change are the coastal elevation. Is it a very steep shoreline, in which case sea level rise can't go very far inland, or is it very gentle slope, in which a little bit of sea level rise will go far inland? Second is the rock type. Is it a very hard rock that won't erode? I often think the cliffs all around Newfoundland land. Or is it a very soft rock that erodes very easily, such as the sandstone cliffs in PEI? I think around here we're somewhere in between, but a bit more on the erodible side. The third item is wave height. How much the wave height will increase, the extent to which the waves can erode the shore. And finally, whether the land is rising or falling. This final point is very important to understand that Fred is going to explain some of the mechanisms. But very quickly, as a result of the last ice age and the glaciers leaving, the land here is naturally sinking. Very slowly, on average, about 30 centimeters per century. Depends on where you are. So, just to make this point, we don't have to go very far. We just go down to Lewisburg. And this is a really interesting picture. It was taken, I believe, back in the 60s when the fort was being restored. You see the lady on the right, she's holding on to a mooring ring. Now, it makes sense to me that when the fortress was built, that mooring ring would have been put above the high water mark. There's really no sense in putting a mooring ring below high water. So that's just a crude estimate, but a pretty good indicator of where high tide was back in the 1740s. At the time this diagram was prepared, so that's roughly a meter over 250 years, several feet. And that's a really good indication, or a really good record of the fact that sea level is rising here, in part because the land is sinking, but also in part because the ocean has been slowly heating as well. So that certainly has implications for this part of the world. Coastal erosion is certainly a concern here, especially with cliffs like this, where a lot of the wave action can undercut the cliffs, and because they're so steep, you can't necessarily see it until it collapses all around you. A lot of wave action pounding away on the cliffs. This is a phenomenon that's certainly of concern now, and climate change models with increased storminess suggest that wave action may be of greater concern in the future. Winter storms. Picture the Canso Causeway, I think from 2004, a particular storm that closed the causeway. And the causeway does get closed from time to time in the winter. And functionally, that cuts off Cape Breton from the rest of the mainland. It has implications for economy and transportation and convenience and emergencies. This is an example of what if climate change is going to make it more vulnerable in the future, we have to be very aware of that. Winter storms, a big one back in January, you may recall. These are some pictures from Florence Beach up the coast. And then the aftermath on Dominion Beach. And you look at the amount, if you've been there and you've noticed the amount of cobbles that got pushed up onto the boardwalk and into the parking lot, even if you weren't there during the storm, think about the amount of energy of the surf pounding, enough energy to push all of that rock that far. A few more pictures. You can see this is one of the side boardwalks that goes from the main boardwalk out to the beach. Here's one end of it. There's the other end of it over there. The rest of it is entirely buried. So in terms of adaptation, we have to start thinking about, well, if this kind of event's going to happen more frequently in the future, do we want to have to rebuild this boardwalk every few years if these storms are going to damage them more and more in the future? So maybe we might think about building them differently, putting them in a different location, or moving them back. Things like that. These are questions we might not have asked in the past, but we should ask in the future, because municipalities and provinces don't have endless amounts of money to keep rebuilding things. So it makes more sense to build them smart in the first place. And then just looking back, you can see that the pebbles got washed into the parking lot closest to the beach, but not so farther back. And we can make an observation about adaptation here, in that people still want to come to look at the beach, even though it hasn't been cleaned up yet. And they can't necessarily park down where they used to, so they park farther back. Sea ice is another important variable to mention. Winter storms are always of concern, but sea ice has an effect of actually protecting the coast to some degree. If you have a lot of pack ice along the coast and a big storm comes, the wave erosion the erosion caused by the waves tends not to be so bad. Now, sea ice can be a double-edged sword in that if you have a lot of it and there's a storm surge and you have very low-lying coast, the storm surge can actually lift the ice up and push it inland and damage buildings. But the reason I bring this up is in the future the climate change models are predicting that there will be less and less ice being formed in the Gulf of St. Lawrence and coming out this way. So we have to think about a future in which at some point in the future there will be no protection of the shoreline in the winter from ice. And just to make a point about the variability and sensitivity to ice, I've got two satellite pictures over the Gulf of St. Lawrence. And they're taken in March, first one from 1987. And you can see most of the southern Gulf is iced in. The second picture, almost the same day, 20 years later, hardly any ice. Very little is left at this point. And this basically falls into natural variability, but it makes the point that sea ice is very sensitive to changes in climate, and it supports what the computer models are saying, that because it's sensitive, in the future there will be a lot less of it. So I've alluded to this concept of adaptation, but I want to introduce it a bit more formally. The IPCC defined it as natural or modifications to natural or human systems in response to changes in the environment or climate. So it's either changing what we do or animals changing their practices to try to better adapt to a new climate. Reasons for undertaking adaptation is regardless of what we do in terms of greenhouse gas reduction, some climate change will happen. We're on the road to change, and it's not whether the climate will change or not, it's how much the climate is going to change. The second point is adaptation is supported by the philosophy of it's a lot better to be prepared for adversity in the future than it is to react after the fact. And the third point is a lot of adaptation strategies will increase our resilience to current climate variability. If you think about some of the really bad storms and other extreme events we've had in the past and how our communities have struggled to deal with those, if you imagine that climate change is only going to make those events worse, then we really need to increase our capacity to respond. And even if climate change doesn't get as bad as we fear it may, it will actually help us to react to the current extreme events we're having. And the final message around adaptation is there are some impacts of climate change we can adapt to, but for other impacts, adaptation is just not practical. If coastal erosion becomes so bad at a particular point that the point gets washed away, it's just not possible to shore it up, and it's probably best to retreat from that location and focus our efforts on particular spots where it is practical to adapt. A few examples of adaptation. The town of Annapolis Royal did a lot of early mapping of storm surge